Bismillahirrahmanirrahim. Today I will be starting a new course for students of O level and IGCSE student. And throughout this course, I will be your facilitator, and my name is Noman. And from the first lesson, we will do numbers, and in numbers, we will do types of numbers. So, the learning outcome for this topic is we will introduce what are integers and natural numbers, and what are rational and irrational numbers, what are multiples, factors, prime numbers, squares numbers, cubes and roots, and also reciprocals. So let's get started with the first one, the first learning outcome, which is what are integers and natural numbers. So we can define integers that integers are the whole numbers, and also integers can be positive, negative, and zero. For example, any number that we have -10, -11, 0, 10, 11, 12, -3, -2, -1, 0, 1, 2, 3, all of these numbers are integers. And after that, we have natural numbers. So natural numbers are the positive integers. Only the positive integers are the natural numbers. And also you need to keep in mind that 0 is not included in the natural numbers. So it means that the natural number starts from 1, 2, 3, and so on. So this is all about integers and the natural numbers, which is very simple. And after that, we will move moving forward towards what are multiples now. So a multiple of a given number is a number that can be formed by multiplying the integer by any other positive integer. For example, if a number is 12, let's say we have a number 12. So 12 is a multiple of 3. How 12 is a multiple of 3? Because we can make 3 times 4. What is 3 times 4? Because 3 times 4 make it 12. So we can say that 12 is a multiple of 3. And after that, we have a common multiple. A common multiple of two or more integers is a number that is a multiple of integers. For example, we can say that 12 is a common multiple for 4 and 6, because 12 is a common multiple of 4 and 6. How 12 is a common multiple of 4 and 6? Because 3 times 4 is 12, and also 2 times 6 is 12. So 12 is a common multiples of 4 and 6. And after that, we have even numbers. So even numbers are like 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. These are even numbers are the multiples of 2. So all of the even numbers are multiples of 2. And then we have odd numbers, like odd numbers are 1, 3, 5, 7, 9, 11, 13. These are not the multiple of 2. And also, multiples can be algebraic, like we can write down k, or we can write down 2k, we can write down 3k, we can write down 4k, 5k. All of these numbers are algebraic multiples. So in this, we have covered what are multiples, and in which we have covered the multiples, then common multiples, then even multiples, odd multiples, and algebraic multiples. And after that, factors. Factors are very important, because later on we will be working on factors also. A factor of a given number or an integer is a number, is a value that divides the given number exactly with no remainder. For example, let's say if 6 is a factor of 18 or not, we can find out 6 is a factor of 18, because 18 divided by 6, when you will simplify this, 6 times 1 and 6 times 3, you will get an answer 3 without any remainder. Without any remainder. So it means 6 is a factor of 18. So every integer which is greater than 1 has at least two factors, the integer itself and 1. And a common factor, what is a common factor? A common factor of two or more integers is a number that is a factor of the integer. For example, 3 is a common factor for both 21 and 18. 3 is a common factor for 21 and 18, because 3 times 6 makes it 18, and 3 times 7 makes it 21. So we can say that 3 is a common factor for both of the integers, which is 21 and 18. Okay, the next thing is that how can we find out the factors? So finding all the factors of a particular value can be done by finding factor pairs. So in this case, we will be finding the factor pairs. So for example, when finding the factors of 18, let's say we have 18. So we can say that 1 and 18 will be the first factor pair, because the factor itself and 1 are also the factors. And after that, we need to divide the number 18 by 2, 3, 4, and so on to set test to find out if these are factors or not. So the first one is 18 is divided by 2. If we do 18 divided by 2, we can find out 9. So it means that 9 and 2 are the factors of 18. If we do 18 divided by 3. So we can find out 6. So it means 3 and 6 are also factors for 18. If we do 18 times 18 divided by 4, so we can find out it gives you an answer which is 4.5, which is exactly not an integer. It gives you the decimal part. So we can say that 4 is not a factor of 18. 4 is not a factor of 18. After that, 18 divided by 5, we can see that it gives you an answer 3.6, which is not exactly an integer. It gives you the decimal number. So 5 is not a factor. And when 18 divided by 6 would be the next. So we have already done that 6 is also a factor. So we find out that the factors of 18, the factor pairs are 1 and 18, 2 and 9, 3 and 6. So we have now found all the factors of 18, which includes 1, 2, 3, 6, and 9. So the factor pairs for 18 are 1, 2, 3, 6, and 9. So this was very easy. And after that, we have how do I find factors without a calculator? So let's say use a divisibility test. We need to use the divisibility test, and these are tricks to find out if a number is divisible by 2 or not. Let's find out if a number is divisible by 2 or not. We need to see the last digit. If the last digit is 0, if the last digit is 2, 4, 6, or 8, it means that number is divisible by 2. Like we have a number 128. We can see that the last digit is 8. So this number is divisible by 2. We have another example here like 123. 123 is a digit. We can see the last digit is 3. So this is not divisible by 2 because it ends in a 3. But if we say 134, we can see that the last digit is 4. It means it will be divisible by 2 because it ends at 4. Okay, next thing. Now we need to find out the numbers that are divisible by 3. Now we need to find out the numbers that are divisible by 3. So the sum of the digits, what do we need to find out? The sum of the digits must be equals to 3 or maybe 6 or maybe 9. If the sum is bigger than 9, if you can if you can get that the sum is bigger than 9, then repeat the process. Like in the first case, we have a number which is 1, 2, 3. So 1, 2, 3, and when we add these numbers 1 plus 2 plus 3, what you will get? You will get 6. So you see, this is 6. So we have the sum of the digits, which is 3, 6, or 9. It means this number is divisible by 3. This number is divisible by 3. And let's say we have another number, which is 2574. Let's say we have 2574. So when you will sum up all of these digits, it will give you 2 plus 5 plus 7 plus 4, and you will get, what is it, 18. And if you split the 18 into 1 plus 8, it will give you 9. You see, you get 9. So it means that this number 2574 is also divisible by 3. Very simple. After that, we need to find out if a number is divisible by 4 or not. And the rule is the last two digits can be halved twice to give the whole numbers. Like we have the first example here, 528. We need to find out 528. We need to see the last two digits. So 528. In 528, the last two digits is 28. And let's divide it by 2. And if we divide it by 2, it gives you 14. And 14 divided by 2, it gives you 7. So what we have done, the last two digits can be halved twice. We have the last two digits, which is 28, and we have halved it twice. And we see that it's halved twice. It means this number, 528, is divisible by 4. In the next case, if we have a number, let's say we have 4274, which is not divisible by 4. How do I get it that it is not divisible by 4? Because the last two digits are 74. So if we do 74 divided by 2, we will get 37. And if we do 37 divided by 2, we get an answer in decimals. It means that the twice number is not half. It means this number 4274 is not divisible by 4. That is very simple rule to find out the number that is divisible by 4 or not. And after that, we have to find out the numbers that are divisible by 5. Again, the rule for this is very simple. We need to look for the last digit is 0 or 5. So we can see the first number is 3025. The last digit is 5. It ends at 5. It means this whole number is divisible by 5. In this case, 2719, we see that the last digit is 9, which is not 0, either not 5. So in this case, the number ends at 9. It means this number is not divisible by 5. Then we need to find out if the number is divisible by 8 or not. So the last three digits can be halved 3 times. Okay, in this case, we need to do the last three digits and we need to halve them three times. Like we have the number 2144 and the last three digits are 144. And if we divide it by 2, you will get an answer. Divided by 2, you will get an answer 272. Then 70 divided by 2, you will get an answer 36. Then 36 divided by 2, you will get an answer which is 18. So when we have done the last three digits, half it by three times, we see that each time we get an answer. We get an integer. It means this number, this whole number, which is 2144, is divisible by 8, right? And after that, we need to find out the numbers that are divisible by 9 or not. So the sum of the digits is a 9. If the sum of the digits is bigger than 9, then repeat the process. Like in the first case, we have 423. 423, let's sum this. We have 4 plus 2 plus 3. It will give you 9. It means this number is divisible by 9. We have another number which is 2574. When you will sum all of these numbers, digits, you will get 18. And 18 is 1 plus 8. When you will do 1 plus 8, it gives you 9. It gives you 9. It means still it gives you 9. This number, what number? 2574 is divisible by 9. And then we have the last one, which is 134. So 134, when you will sum all of these digits, which is 1 plus 3 plus 4, which is not divisible by 9. 1 plus 3 plus 4, it gives you 8, not 9. So this number 134 is not divisible by 9. And then we have the last one. We need to find out if the number is divisible by 10 or not. So in this case, the last digit is 0. Like in this case, you can see the last digit is 0. This number is divisible by 9. Then we need to say that the last digit is 5. This number is not 0. The last digit is not 0. It means this whole number 3025 is not divisible by 10. So these are some simple rules or tricks you can say that you can use to find out which number is divisible by 2, 3, 4, 5, 6, 8, 9, and 10, and up to so on. Okay, let's move forward. So the next topic is, once you know that the number has a particular factor, you can divide by that factor to find out the factor pair. If the number is not divisible by an integer, then the number is not divisible by any other multiple of that integer. Like in this case, 119 is not divisible by 3. 119 is not divisible by 3. It means that 119 will be not divisible by any factor of 3, which is 6, 9, 12, etc. 119 is not divisible by 3, not divisible by 6, not divisible by 9, not divisible by 12. And then next thing is, if a number is divisible by two integers and the only common factor of those integers is 1, the number is also divisible by the product of integers. Like we have the number 594 is divisible by 2 and 3. We see 594 is divisible by 2 also, and 594 is also divisible by 3. So the only common factor of 2 and 3 is 1. And we can also see that 594 is also divisible by 6 because 2 times 3 is 6 also. And instead of the divisibility test, you can use the formal written method. Okay, after that, later on, we will talk about this. But for now, we need to see what are prime numbers. This is very important. And what are prime numbers? A prime number is a number which has exactly two distinct factors, itself and only one. A number which is exactly two distinct factors, the number itself and one. Like we have 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. All of these numbers have only two distinct factors, themselves and only one. One is not considered to be a prime number because by definition, prime numbers are integers which are greater than 2. So prime numbers starting from 2, later on it adds to 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. So 2 is the only prime number in the prime numbers, and all other numbers are odd numbers. If a number has any factor other than itself and 1, it is not considered to be prime number. Let's say 6. We see 6 are the factors. Factors of 6 are 1, it has 2, it has 3, it has also 6. So it has more than two distinct factors. It means 6 is not a prime number. Only those numbers that has only two distinct factors, itself and only one, these numbers are considered to be the prime numbers. We have a worked example here, like we need to show if 51 is not a prime number. If we can find a factor of 51 that is not 1 or 51, we will prove it is not a prime number. Let's say 5 plus 1. If we see 5 plus 1, because 5 plus 1 will give you 6. So this number is divisible by 3 also. 51 is divisible by 3. It means 51 is divisible by 3. So we can find out the factors for 51. 51 has the factors of 1, 3, 17, and 51. We see 51 has 4 factors here. So 51 is not a prime number because it has more than 2 factors. After that, we have square numbers. What are square numbers? A square number is the result of multiplying a number by itself. Like we have a square numbers 1 times 1 is 1, 2 times 2 is 2, 2 times 2 is 4, sorry. Then 3 times 3 is 9. So these are square numbers. Up to so on, you can say 5 times 5 is 25, 6 times 6 is 36, 10 times 10 is 100. So these are first 15 square numbers given here. 1, 4, 9, 16. Then we have 10 times 10 is 100, 11 times 11 is 121, 12 times 10, 12 is 144. 13 times 13 is 169, 14 times 14 is 196, 15 times 15 is 225. All of these numbers are square numbers. And also in algebra, square numbers can be written as the power of 2, like a square. This one is also a square number, b square. This is also a square number, c square. So this is also a square number. And after that, we have the cube numbers. Cube numbers are also very simple. A number is the result of multiplying the number by itself twice. We need to do it twice. Like, like in this case, very simple example, 2 times by 2 times by 2. So we can write this one as 2 times 2 to the power 3, which is equals to 8. So first 5 Q numbers are given in this case. Like in this, we have 1, 8, 27, 64, and 125. And also, if you can find out, if you need to find out the cube number for 10, so 10 to the power 3, it will give you 1000. And in algebra, we can express the cube numbers as a to the power 3, a cube, b cube, c cube. All of these numbers are cube numbers. And after that, we have what are square roots. So the square root of a value is the number that when multiplied by itself equals that value. For example, 4 is the square root of 16. You see, 16. If we need to find out the square root for 16, we know that 4 times 4 make it 16. So what we can write down? We can write down, instead of 16, we can write down 4 square. And this square will cancel the square root and it will give you an answer which is just 4. So which example, 4 is the square root of 16. That is it. Okay, let's say the square root is indicated by the simple root, and the positive root for 49 can be written as, let's say we have root 49, and we need to find out the square root for this. So it will be written as 7 times by 7, right? So what we can write down? We can write down 7 square instead of 49. So square will be cancelled by the root and we'll get an answer 7. So the square root can be positive, and when you will solve this, you will get two answers because we need to write this one as plus minus 7. It will be two answers, positive and negative also. Like the square root of 25, because 25 is the perfect square for 5, so we can write down the answers as positive 5 and negative 5 also. So if a negative number root is required, then the sign negative will be written. So sometimes both positive and negative square roots are one of the interest and would be indicated. The square root of a non-square integer is called a surd, is also called a surd. What is a surd? A square root of a non-square number. Like we have a non-square number, root 3. So root 3 is a surd because 3 is not a square number. So surds can be irrational. Surds are irrational, but it can be rational because root 64. Root 64 is rational because when we'll solve this, we will get an answer of 8. However, root 2 is irrational. Why root 2 is irrational? Because it is not a square number. So this one is irrational. You should aim to remember the square roots of the first 15 numbers. You should, like, the root 4 is 2, root 9 is 3, root 16 is 4, root 25 is 5, root 36. What is root 36? The root 36 is plus minus 6. What is root 49? Plus minus 7. What is root 64? It is plus minus 8 up to so on. You need to memorize at least first 15 square numbers or the first 15 root numbers. And after that, what are cube roots? Cube roots are the ones in which when multiplied by itself twice equals to that value. For example, 3 is the cube root of 27. Okay. So if we have cube root, how do we write down the cube root? We need to write down 3 here, then the root, and we now write down 27. So inside the cube root, what I can write down now? So we can write down 3 to the power cube. Because 3 to the power cube equals to 27. Now we can cancel the cube with the cube root, and ultimately we'll get the answer 3. So, for example, 3 is the cube root of 27. It is inverse of cubing. Cube roots are introduced by the symbol third root. This could be written as third root, like this. Like let's say another example. We have third root of 8. We have third root of 8. I can write this one as third root of 2 cube. Third root of 2 cube. I can cancel this one with this. So we'll get the answer, which is 2. So the cube root of 64 would be written as cube root of 64. So we have some examples here: cube root of 1, cube root of 27, cube root of 64. We have a worked example here. Write down a number which is both a cube number and a square number, hence express this number into two different ways. Listing the first 12 numbers, square numbers are 1. We have first 12 square numbers, which are 1, 4, 9, 16, 25, 36. So these are all first 12 square numbers. And in these square numbers, we can write down this is 64. Now list down the 5 cube numbers. So like 5 cube numbers are, the first one is 1, 8, 27, then 64, then we have 125. We can see 64, 64. These are the same. So 64 appears in the both list. It is the 8th square number and the 4th cube number. So 64 is both a square and also a cube number, because 64 can be written as 8 square in the form of square, and 64 can be written as 4 to the power 3, 4 cube. Okay, the last one. Last one is, what are reciprocal? What is a reciprocal? The reciprocal of a number is the result of dividing one by that number. Like we have an example, any number multiplied by its reciprocal will be equals to 1. The reciprocal of an integer, 1 over integer, let's say we have a over b. If we need to find out the reciprocal for this number, I can write down b over a. This is the reciprocal for this number. Like we have 3. So to write down the reciprocal of this number, it will be 1 by 3. So when you will solve this, because when you will solve this 3 times by 1 by 3, you will get an answer which is just 1. When you will solve 3 times by 1 by 3, you will get an answer on 1. So any number multiplied by its reciprocal will be equals to 1. Then we have so many examples here. Like the last one is a times by 1 over a, because a is simple number and 1 over a is the reciprocal for a. A is the, so in this case, a is the simple number, a simple integer, and 1 over a is the reciprocal for this. When you will solve this, you will get an answer of 1, because we can simplify these numbers. So after that, we have a work example here. Write down the fraction that completes this calculation. We have 3 by 7. What times by 3 by 7? So it gives you 1. So this is very simple. You can times it by 7 by 3. Recall the number multiplied by the reciprocal. We need to find the reciprocal for the 3 by 7. So that is simple. And I hope you guys understand, and see you in the next video. Thank you.